Hi everyone. Today's video is about 3D sketches. I'm going to be talking about how to use them and where they are useful. Let's take a look at this part. This is called an icosahedron. It has 20 faces, each face being a triangle with a side length of 1 inch. At first glance, you may not think this part is overly difficult to draw, but then take a minute to think about how to make it. Probably isn't the best idea to extrude because there are hardly any faces that are parallel to each other. Revolving won't work because there aren't any round faces. Lofting might be possible. If you see at the top, you have a pentagon here. You can loft up to a point, but then think about how to do the middle. How do you get one vertex to diverge to 2 points and 2 vertices to converge to 1 point? So that's not really possible to do that either. So this is a good case where a 3D sketch can be useful. Now, since the concept of this part is fairly simple, all these lines are still 1 inch long. So let's start with what we know. So we have a new part. Take a sketch, make it on this plane. Go to Polygon, 5 sides. Take side length, 1 inch, and finish the sketch. And now to loft the point on top, we need to know how high up this point is. So create a sketch on this plane, since we still know that the side length of our stuff is all 1 inch. So if I take project geometry, this point here, I can take a line, draw up from the center to this point, dimension it 1 inch, and we can see our point is here. Alright, finish the sketch, and now go to loft from the pentagon to the point we just drew. Make it 2D, you'll see why in a minute, and hit OK. So now that we have this, we can start our 3D sketch now that we have something to reference in. So if you go down to the drop down next to 2D sketch and go to 3D sketch, we start a 3D sketch. Alright, so now the first step is to include the geometry we want to reference in. So if we go include geometry, select all these, and now we can start drawing lines. Alright, the first step here would be to connect all these points, because that stuff is going to be included in what we are drawing. And then each of these faces, each of these lines, I should say, are going to form another triangle. So we can draw a triangle there, triangle there, and just repeat the process for all the sides. Once you got those, you can connect the endpoints just like this. Now that we have our geometry drawn, we can dimension it. 1 inch there, 1 inch there, and it's going to be the same all the way around. So at this point, I like to sort of move it into the position it's supposed to be in before finalizing the dimensions. So now I have to define the length of the bottom here. Okay, so once that's done, you can sort of check to see it all lines up properly. So if you go to this view, the lines match up properly. This view looks nice also. And so we can finish that sketch. Um, this sketch looks a bit messy with all the dimensions, so if you want to sort of clear it up, we can go to the sketch and uncheck dimension visibility. So once we have our sketch drawn, the next step is to fill all these triangles in with boundary patches. Take the side lengths, patch there, grab our sketch back, and just repeat the process until all these are enclosed. Alright, so that's there. We can turn the sketch off. We don't need it anymore. So at this point, the part is almost done. We just need to draw the bottom in a similar way that we've drawn the top. So if I go to plane, at this point, parallel to there, creates a plane there. 2D sketch, can project, cut edges. So it gives me my pentagon here. New sketch. Start a new one. There. Take a line from here to there. Dimension 1 inch. Point here. And we can loft. 2D again. From that pentagon to that point. Okay. And now, since we got here knowing what we do about 2D geometry, we can stitch all these lofts and boundary patches together to make the object solid. Okay, so the next part I wanted to make is this one here. This is called a dodecahedron. It has 12 sides. Each one is a pentagon with a side length of 1 inch. Now, if we were to approach this part in the same way as the last one, we go new part, make a pentagon at the top, patch that, and then we'd start our 3D sketch. So our 3D sketch here include the geometry of all these sides, and then we start drawing our other pentagons. So we have that one there, and that one there. Dimension the sides 1 inch apiece. Alright, so now at this point you would expect this sketch to be fully constrained, but unfortunately it isn't, because I can click this, drag it here, sketch moves. That's because the points of this sort of pentagon here are not all coplanar. and they need to be, but there really isn't a coplanar constraint here. But still, you'd think this part is pretty simple to make, because it's sort of just an assembly of pentagons of 1 inch. So why don't we do that? Why don't I get rid of this, make work points here, and I can use this to sort of assemble my part together. So if I go New, Assembly, and place in all the pentagons that I have. It's going to be 12 of them. And just connect the points to assemble. See how it just sort of snaps into place like the sketch couldn't do? That's what we want. So if you just repeat this process and assemble all the pentagons together, the figure will be sort of complete for us. Alright, so now that we've got our figure sort of assembled, we can we would normally sort of stitch all these together, but unfortunately there's no stitch command for assemblies. But that's okay. So knowing what we know about in-place components, we can create one. And then, using a 3D sketch, we can include the geometry of what we have. Finish there. Turn. Alright, so we have that. And now, in our part, we can just do the same thing that we did last time and use boundary patches to enclose this figure. Alright, so now that we've got that, just do the same thing we did. Stitch all the boundary patches together, and we have a solid part. And if we wanted to isolate this part, we can just right click, open, and here we go. So this technique of working backward from assembly to part is useful for creating other things. For example, we have this excavated icosahedron here. We have this small triambic icosahedron, and the buckyball. So that's about all I have for now. As always, I hope you've learned something here, and I'll see you later.